to the next slide, what are the actually the features of this PIC 18452 microcontroller. So you know that it's a 8-bit processor with 8 channel of 10-bit analog to digital converter. So PIC 18452 feature a C compiler friendly development environment, 256 byte of EEPROM, self programming, and ICD 2 CCP module. So all this terminology I will be discussing in the coming slides. So it's a high performance RISC CPU, up to 10 millions instruction per second operation, and 16 wide instruction, 8 wide data bus, and it has 3 external interrupt pin. Master synchronous serial port module is there. Then it has PLVD, programmable low voltage detection, and programmable brownout reset pins are there, facilities are there. Then it has flash data EROM retention of more than 40 years, self-programmable under software control, watchdog timer, programmable code protection, power saving sleep mode, single supply 5-volt in-circuiting serial programming, then in-circuit debugger, CMOS technology, local. So I will, this is the terminology, one by one I am going to discuss this features. So in short, you can see that the number of pins in PIC 18452 is 40. Its CPU is 8-bit processor. Its operating voltage, you can see that 5.5 volt. The program memory is 32 kilobyte, and instructions, program memory instruction, that is 16384. Oscillator startup timer is available. RAM size is 15.36 byte. EEPROM size is 256 byte, and there is 10-bit ADC. It has 5 input output port, A, B, C, D, E, and it has 40 pin. Watchdog timer is available. External oscillator, its speed is up to 40 megahertz. So it has 4 timers, 3 16-bit timer, 1 8-bit timer. It has UART protocol, it has I2C protocol, it has SPI protocol. It has a provision of brownout reset. It has comparator, master synchronization serial port is available. It has CCP module. It has power saving sleeping mode. It has selectable oscillator options. So its speed is up to 40 megahertz. So, and it has operating high current sink and source. So one by one I'll discuss this features. So basically 18F series, it is 8-bit processor with 14-pin DIP package that can operate at a speed from DC to 40 megahertz. So it's a 8-bit processor. It operates on low voltage. It has high speed CMOS flash technology, fully static and a RISC design, and has a Harvard based architecture which can work on a wide operating range from 2 volt to 5.5 volt. Okay, so it has total 40 pins. Out of these 40 pins, 34 pin can be used as an input output. So you know, it has 5 port, A, B, C, D, E ports. So from A, 7 pin can be used as an input output. From B, C, D, all the pin, 8 pins can be used as input output, while from E port only 3 pin can be used. So it makes total 34 input output pin, while some of the other pin are used in a multiplexed fashion. They can be used to interface the peripheral. They can be used for the timer, for master reset, for power supply, and let's see. So here In this port, basically 3 registers are there. I am focusing on the register inside this port. I am not discussing the register inside the CPU. Register inside the port, so it has basically 3. That is Tyrus register that will define the data direction, that is whether the particular port pins are using as an input or an output. Then port register read the label on the pin of the device, and then a latch register, so it reads the input or it reads the input port irrespective of the changing of the voltage. So it's a latch, it sends the ports or pins towards the latch condition. So these are what the Tyrus port and latch, the 3 register is available. And this PIC 18452, as per the data set, 77 instruction sets are there. It has 4 timer, 3 16-bit and 1 8-bit timer. So all the 3 timers, basically the timer mode mainly increment the instruction cycle, but the counter mode is used to increment the rising and falling edge of the pins. So this is what the timer registers. Then you know that this follow the Harvard architecture, so it uses 16 wide instructions. So remember that address bus and data bus, this will have different numbering of the data, and address bus will be different. But here you focus. I will tell you to focus on the size of the instruction and size of the data. So since it is 8-bit, so the data path is 8-bit, while the instruction it will fetch from the program, because program memory. So it will fetch 16. All the instruction set is what all the instruction is having a length of 16-bit. Okay, so it will fetch instruction from the program memory, while the data from the data memory, because you know that it follows the Harvard architecture. So if it is fetching instruction 16-bit wide instruction, so 21 address lines are there. So 21 address lines are there to fetch the instruction. And if you see that 2 to the power 21, so that is 2 MB ROM. So the capacity of ROM is 2 MB, while for fetching the data it uses 12 address lines. So to access the memory of the RAM, okay, so RAM basically store temporary instructions and data. So what to fetch the memory of the RAM, because whatever the instruction and data will be stored in some memory. So first to access the memory, so to fetch memory from the RAM, it uses 12 address buses. Okay, so the capacity of RAM is 2 to the power 12, and that is 4 KB. So it has also 32 KB of flash RAM. It has 256 of data EPROM that is used for storing the critical information. So you can see that the highlight of, I will again you can separately see the data memory and the program memory. So 21-bit address buses to accessing the memory location of program memory. So 2 to the power 20, twice of MB, 2 MB what the program memory capacity. 12-bit address buses for data memory with addressing capacity 4 KB, and instruction, you carefully observe that it has 16-bit instruction and 8-bit data for the data memory. It has high performance RISC CPU. It has 3 external interrupt pin. So now I will go to program memory. So what is that program memory? So actually a program memory that contains the program which is written by the user and loaded on it. So the program PIC F452 have 16 bit of program memory register that can be electrically erased and reprogrammed several times. Okay, so it has 21 bit address buses to access this program memory. So the capacity is 2 to the power 21, that is 2 MB, and it consists of this program memory section also consists of a program counter and stack memory. So a program counter is a processor that holds the memory address of the next instruction to be executed by the computer. So the program counter is usually incremented after fetching an instruction, but can be changed by control transfer instruction like branching, call and return. The program counter may revert to a specific value when computer restart or is reset. What the working of stack memory, stack pointer? So stack pointer holds the address of stack top. The stack is a sequence of RAM memory location defined by the programmer. The stack is used to save the content of register during the execution of program. The stack pointer is also a register that is used to point into the memory. The memory used for the memory that points the register in a special area we call the stack. So the stack is an area of a memory used to hold the data that will be retrieved soon. So the stack usually access in last input first output fashion. The stack is a segment of memory that is stored temporary variable created by a function. So we can observe clearly the importance of stacks here. So what other features that make this PIC 18F452 microcontroller unique and ease of use? So we can see that it has a wide operating voltage range 2 to 5.5 volt. It has multiplexed master clear with pull up with input pin, in circuit serial programming, power saving sleep mode, C compiler, optimized architecture, industrial and extended temperature range, power up timer and oscillator startup timer, power on reset, in circuit debug via 2 pins, brown on reset with software control options, and watchdog timer. So one by one I will discuss this advanced features in the PIC that make it very useful with different kind of application that is used in the industry or in several areas. So let's see what is the function of all these features that is available with this 18F4520 microcontroller. So timer, you know that the PIC 18F4520 come with 4 timer, 316 bit and 1 8 bit timer that can be used as a timer as well as counter. So all the 3 timer contain internal and external clock select capability. The timer mode mainly increment the instruction cycle, while the counter mode is used to increment the rising and falling edges of the pin. So you know clearly the timer basically is in so many delay operation we use the timer, and so many count operation if it is using for a brown on reset or master reset, so or for some kind of other application, so counter mode is used. So this timer has importance with any kind of microcontroller. Then brown out reset. So brown out reset is a very useful function that allow this controller to reset once when the supply voltage drops below a brownout threshold voltage. So you know that it's work with variable voltage range from 2 to 5.5. So a timer is kept enabled, and when it will see that the voltage is below a certain voltage, then it will automatically reset the microcontroller. So what is in-circuit serial programming? So in-circuit serial programming, also we called in-system serial programming, is a feature added to the device that make it enabled to be programmed in the required system after installation. So setting it free from programming the device before making it compatible with certain means, if you have configured your hardware and if something if you want and the programming, in programming you have defined different ports, you have assigned different ports and register, and you have connected somewhere hardware with different ports, so you no need to unplug the hardware and to plug with that program. Here what in circuit programming means, in your program you can assign those pins to the those pin in the programming where your hardware is attached. So without disturbing the hardware configuration, you can reconfigure those hardware with your programming, which is called what, in circuit serial programming adjustment. So this feature is added with this PIC. Now come to this UZAT module. So you know that this is used for universal synchronous and asynchronous transmitter receiver, that is basically used for the serial communication with external devices. So there are two part, transmitter and receiver, where former is known as transmitting component, that is used for transmitting serial data, while rather is, so what you know that if you want to transmit bit by bit, because inside the processor many things communicate in a parallel mode, but outside the peripheral, if you want to communicate with the peripheral external devices in a parallel mode, so many wires will be used, so that work in a serial communication, so bit by bit transfer happens there. So what it converts the parallel into serial, and then whenever it is taking any data from the external peripheral, so then it will convert that serial data into parallel. So that is what basically this UZAT do. So what this the working of UZAT here in the PIC 18F 452 microcontroller. Watchdog timer is what one of the important characteristics in this PIC. So if a program hang-ups during compilation or got stuck in an infinite loop, so what, this timer must be reset to the initial value after every 3 instructions in order to avoid it going to 0 value in normal condition. So the watchdog timer is more or less a countdown timer that is start from 1000 and ultimately goes down to 0. So what that if a program hangs, because what we wait for the instruction to be executed in a pre-specified time duration, and if we are not getting value from that part of instruction, then what, this watchdog timer will help and will reset this program, and again the compilation will start. So this is the use of watchdog timer here. Then power on reset function, this is very helpful, and reset the controller and start it from the scratch when VDD supply voltage raises above a certain threshold value. So this function is very useful to prevent the device from the malfunctioning. So now we'll come on the power managed mode, that is also available with this PIC. So the power managed mode are mainly divided into 3 main categories. So how it will manage the power: run mode, sleep mode, and idle mode. Even in run mode, where to supply the power, that is available here, that is programmed here. In sleep mode, it will save the power. In idle mode, it will also use to save the power. So what functioning it will do in the run mode, what little functioning it will do with the idle mode, and what functioning it will do with the sleep mode, that are defined here with this PIC microcontroller. So this power managed mode, now Master clear reset mode. This master clear pin is used for calling the external reset for the chip. So that program power reset and that brown on reset, those were the internal reset. This one is the external reset. So when you trigger, the reset is triggered by keeping this pin at a low value and is not dependent upon the internal states. Now PLL phase local loop circuit is used and is new to the PIC 18F series and provide the option of multiplying up the oscillator frequency to speed up the overall operation. So you know that this can operate from the frequency range 0 to 40 megahertz, so that variable speed can be achieved with the help of this PLL. In circuit debugger is the same thing that I discussed